Greetings and welcome to this episode 12 of Living Off the Grid in the City. Again, this is your host, Hector Vladimir Bello. Today, October 23rd, 2015. Today we have probably a short show because it's more or less an addendum to the last show on solar technologies. I said that I was going to discuss some of the non-traditional or non-photovoltaic solar technologies that I don't fully understand, but yet I'm familiar with. So I like to share those. And not only am I somewhat familiar with those, but also I am going to soon enough here begin experimenting with those. I invite everyone and anyone that may be able, capable, and willing to experiment with those to do so. And if at all possible, share your experiences, share your advances or any kind of breakthroughs with those. And as always, try to help each other out as far as technologies is concerned, especially those that may enable you to get off the grid. Some of the solar technologies that I would like to discuss, apart from photovoltaics and heat concentrators, are the very seldom discussed and little known technologies of solar thermocouple. Thermocouple technologies go way back, just as photovoltaics go way back into the 1800s. As you may know, or as you may have watched in the Cosmos series, there was a short presentation of or introduction to that type of solar technology, where in France and at a science fair that they used to have back then, and they still do, there was a man whose invention was on display at that certain fair in the 1800s. I will come up with names and dates here shortly, exact names and dates for that. But he basically displayed a invention that consisted of a solar concentrator, which very curiously made refrigeration possible. It was very curious because from heat he was able to create and generate a very cold environment, cold enough to make iced, some type of iced drink or iced food. I don't think it was ice cream. It was something like iced juice or something like that. But nevertheless, it was very cold, very cool, and a rather new invention, and very spectacular, especially at the time. The way it works is quite curious as well. It's a certain metal combination, and together with simple machinery, relatively simple machinery and tubing, where heat, not necessarily solar, but he used solar technology, solar rays, light rays, to concentrate heat into an area and transformed that into pressure. As you may know, heat builds up pressure, and that pressure can be used to create a cool environment. As you may also know, as the pressure goes up, the temperature goes down. This is a physical phenomenon that's well known in the sciences, physical sciences, and it is something that could be readily used to make such a contraption to where you can create cool substances out of a hot medium. This type of technology has been obscured for the most part, but it has been in use in many industries and in some residential applications, such as propane powered refrigerators, which are for the most part non-existent here in the United States. They're unheard of for the most part. Most people don't even know they exist, but they in fact do, and you can acquire them. I'll buy it for much more than your average electrical refrigerator, for obvious reasons, and because there are much less available. Not because they're much more expensive to build, but only because they are distributed so little that their prices obviously and naturally go up. Your compressor, as you may have noticed in your, or even an electric refrigerator, basically creates high pressures with the help of course, the electric motor compressor. And again, that high pressure is used to drop the temperature in a very simple way, using freon valves, tubing. I may go into more detail how this works here shortly, but basically the way refrigeration works is by extracting heat from a certain environment. The more heat you extract, the colder that environment turns, obviously, and this is basically how refrigeration works. The same concept is used in the solar refrigeration technology that I just discussed, and that I will go into detail more about. A basically higher pressure is used to extract heat from a certain environment, therefore cooling whatever other medium you may want to cool, such as water, foods, some type of material or medium like air, for air conditioning, air cooling, etc. Just to touch a little bit on the history of solar energy and photovoltaics first, before I go over some of the other technologies, solar technologies. Alexander Edmund Becquerel, born 1820 and died in 1891, or more simply Edmund Becquerel, a French physicist. He was the first recorded man to observe the photovoltaic effect, or phosphorescence, or phosphorescence. He was the son of Antony Caesar Becquerel, which also was working on this type of field with electrics. As I'm reading here from Wikipedia, in 1839,
At age of only 19, he was experimenting in his father's laboratory. Becquerel created the world's first photovoltaic cell. In this experiment, silver chloride was placed in an acidic solution and illuminated while connected to platinum electrodes, generating voltage and current. Because of this work, the photovoltaic effect has also been known as the Becquerel effect. Huge, huge discovery. And the other scientist that I'd like to discuss or mention is Augustin Mocot, which is the scientist that I told you about, who displayed the invention of solar refrigeration at the Universal Exhibition in Paris. This is in 1878. For this, he won a gold medal in class 54. He was most notably recognized for the production of ice using concentrated solar heat. This is part of the solar thermal energy type of technologies. And again, this has nothing to do, or not hardly anything to do, with photovoltaics or the creation of electric energy. This is purely transforming heat into cold, which is, if you ask me, quite amazing. And before I can discuss how a solar refrigerator works, in a little bit of detail, I would like to go over how a conventional refrigerator works. Basically, when you pass the compressed gas through the coils, which are basically tubes, usually copper tubes of some length, zigzagging back and forth through the length of the refrigerating surface, usually the back of the refrigerator. The warmer gas can lose its heat to the air in the room. Basically, the Freon, as it goes through these tubings, it loses some of its heat because of its increasing pressure to the surrounding area. This effect, or this process, cools the Freon, or the HFC, which changes into a liquid because of the high pressure it is under. And as it changes into liquid, it loses further heat, the same as sweat. Your body loses heat through sweat, through evaporation. The same thing happens with the surrounding areas of a surface when it loses heat through evaporation. When it has liquid and that liquid is evaporated, it loses heat. Basically, when the liquid inside of the tubing evaporates, the tubing itself, or the area within the tube, loses heat. That heat is basically released into the environment, and the cooler temperatures are maintained and increased within the tubing itself. This cooler air within the tubing is basically channeled into the refrigeration area. Very basically, in one sentence, as put in the website, how stuff works. Refrigeration, it's nothing but the evaporation of liquid. When liquid evaporates, it absorbs the heat in its surrounding areas in the process. So all you got to do, if you want to get rid of heat or cool something, all you need to do is coax a liquid to convert it to its gaseous state or vapor state. Okay, I believe this to be a very important concept to understand before I move on. The refrigeration process, if you want to picture this in your head, I may offer a diagram in the website blog especially, and probably a link to my website with the diagram so you can follow. But if you can picture a coil, uh, a coil that is continuous, it doesn't break anywhere, it doesn't have an in or out, it's just tubing that is continuous, it's one loop. A part of the loop is within the refrigerated area, or the area to be refrigerated. It's usually coiled or in a serpentine fashion, basically zigzagging, and that coil continues to the outside of the refrigerator area, usually the back of your refrigerator if you have a conventional refrigerator. And that loop continues and is also attached to a valve, what they call a high pressure valve, and also has attached to it a compressor or motor to compress the medium air or the gas that's within it. Also, there is a gas, now that I mention it, a gas within the coil at all times. This gas could be, various kinds: freon, ammonia, even some types of CFCs, which are no longer, or for the most part, no longer manufactured. But for example, let's say ammonia, which is a gas that, according to how stuff works, it boils at, or evaporates at, negative 27 degrees Fahrenheit. Let's say this ammonia gas is within the coil, and it stays within the coil at all times. Since the coil is continuous, it has no breaks, no way to escape theoretically. And just picture that. The cycle is a refrigeration cycle that begins with the compressor. The compressor compresses the gas, the ammonia gas, in effect raising its temperature and pressure. When you raise the temperature of ammonia, for example, it will turn into a liquid state. So the compressor basically compresses the ammonia gas, turns it into a liquid, and adds pressure to it. This high pressure liquid continues down the tubing or the coil, where it is coiled or channeled to the valve. The gas within the coil goes, the liquid, the high pressure liquid within the coil goes to the valve, high pressure valve, which is basically a small hole, where one side is high pressure liquid ammonia in this case. The other side, remember, the compressor is both pushing and intaking liquid and vapor. So on one side is pushing the liquid ammonia out, and the other side is sucking in effect, the vapor of ammonia, or the gaseous ammonia in. So on the valves, the valve itself has two sides. Of course, it has the high pressure side with the liquid ammonia in this case, and the being pushed into the valve by the compressor. And on the other side, the low pressure side, the ammonia is leaving the valve, being sucked in by the compressor on the other side, and it's leaving the valve. As it leaves the valve, the high pressure valve, it turns again into, it begins to cool because of the high pressure effect of the valve. as it releases the ammonia on one side. On the other side, the low pressure side, the ammonia expands rapidly, thus losing temperature and going back to its gaseous state. Remember, at negative 27 degrees Fahrenheit, it begins to uh, turn into a gas again. Thus, when liquid turns into a gas, basically it sweats, it evaporates, and just as sweating and the evaporation of water on your skin cools your skin, again, this evaporation process cools the tubing to a very low temperature, thus producing the refrigeration. That coil, if you can follow the diagram that I have provided, which carries that cool evaporating ammonia, of course, is coiled and placed within the refrigeration area or in contact with the refrigeration area, thus making that refrigeration area lose heat as well. Thus, and the cooling effect basically is transferred via contact with either air or direct contact with these coils or the refrigeration area, which is in turn in contact with the coils. I went to a little bit of detail explaining the refrigeration process using a compressor, because it is very similar to the solar side of it, the solar version of the refrigerator, this solar refrigerator. And I will go into a little bit of detail for that. The only thing that is replaced, among others, but the main thing that is replaced is the compressor, the electric compressor. And in its place is put, I assume at this moment, some type of boiler, which is powered by solar heat, radiation heat. And I will go into a little bit of details here shortly. The other very simple solar refrigeration technology that has been developed again for many decades in the 1800s, as I mentioned earlier, was also introduced by in 2009 by a British student, Emily Cummins, from Britain. And the basic construction of the refrigerator is quite simple. It takes nothing but the use of, let's say, for example, a cylinder, metal cylinder, an inner metal cylinder, and an outer plastic metal cylinder. In between those two cylinders, of course, those are sealed cylinders on one side at least, on the bottom more preferably. On between these two cylinders, there is a medium or substance, some type of material such as cotton, sand, some type of organic material, preferably. Let's see, I'm reading here on the main article on that contraption. The material could be wool, sand, dirt, any type of organic material that could absorb water and readily evaporate it, allow its evaporation. You basically pour water into this organic material in between the two cylinders and close the cylinders up top and place it in the sun. As the outer area of the outer cylinder is heat up, evaporation of the water inside occurs inside of the organic material. And of course, when evaporation occurs, as it does in your skin through sweating, cooling happens. The cooling effect is in contact, of course, with the inner metal cylinder, thus cooling whatever items you may have inside for cooling. This is sometimes used in the cooling of medicine, cooling of water, the cooling of certain materials in remote areas, and even for those people that may be wanting to get off the grid, this is a very attractive option there, where you can build. It doesn't have to be a cylinder. It could be a box. It could be a cube. It could be any kind of shape you would like. Build this very simple contraption where you have an outer surface, a inner surface, and an in-between material, or as I want to call it, lining, some type of lining material, and put a lid on, cover it, seal it, close it up, and there you go. Watch the temperature drop on the inside of this, which is in effect a refrigerator. It says in the article that I read that a temperature of 43 degrees Fahrenheit could be achieved for up to 2 days with a single replenishment of water. Since it's not a completely sealed, hermetically sealed contraption, water will evaporate out eventually. But this, as you can tell by the 2-day expectancy, that is a very slow leakage, thus making it a attractive and a effective technology there for helping you get off the grid and use electrical free refrigeration. The thermocouple refrigeration is a little bit more of a complex phenomenon, which I will attempt to explain here shortly. And it basically depends on the combination of some exotic metals, which may or may not be accessible to a good amount of people out there wanting to get off the grid.